NiSource has committed to a $28 billion capital plan through 2030, with nearly $7 billion specifically earmarked for data center infrastructure. This investment is the primary driver for their target of 8 to 9% annual EPS growth. EPS, or earnings per share, is a financial metric indicating a company's profitability divided by its outstanding shares of common stock. Looking at this document, we see the recent agreement with Amazon in Indiana. This is a dedicated generation company, or GenCo, built to serve Amazon's web services. It is expected to deliver over $1 billion in savings to retail customers over the contract's life, proving that a growth pays for growth utility model actually works in practice. To hit that $28 billion target, Columbia Gas needs to take the Indiana template and replicate it systematically across its entire operating footprint in Ohio, Pennsylvania, Maryland, Virginia, and Kentucky. Without a standardized playbook for evaluating and onboarding these massive facilities, billions of dollars in planned rate-based growth are left exposed to competing electric utilities and private developers. Right now, Columbia Gas is frequently missing out on flagship data center projects. Those high-margin loads are going to electric utility counterparts or private developers who move faster. This text outlines the gap. Competitors like AEP already have a PUCO-approved large load electric tariff. PUCO stands for the Public Utilities Commission of Ohio, which regulates utility services in the state. Tariffs like this require tech companies to pay for at least 85% of expected usage, protecting regular ratepayers. Columbia Gas currently relies on a case-by-case commercial framework that lags behind these established standards. To capture these high-margin industrial loads systematically, Columbia Gas has to formalize an Enterprise Economic Development, or ED, gas framework. Standardizing tariffs and contracts ensures the utility secures hyperscale clients while definitively mitigating stranded asset risk, the danger of building expensive infrastructure for a project that eventually stalls or abandons the site. The utility is currently facing a massive influx of speculative load requests from prospective data centers, and the existing manual, spreadsheet-based intake processes cannot keep up with the volume. NiSource already uses artificial intelligence for customer experience and field operations. Now they must redirect those AI capabilities toward economic development and interconnection triage. This means shifting to a unified architecture that integrates customer relationship data, geographic mapping, and AI to predictively score potential sites. Generative AI can be trained on past deals and engineering standards to draft fast, consistent RFP responses for hyperscalers. An RFP, or request for proposal, is a document a business uses to solicit bids for a project. The AI automatically embeds strict local regulatory guardrails into every proposal before a human ever reviews it. Deploying these advanced analytics acts as a structural filter. It separates the highly viable multi-billion-dollar megaprojects from the constant stream of speculative market noise. A single monolithic playbook will immediately hit a wall when it meets the unique political and environmental realities of different states. Tier 1 growth states like Ohio and Virginia require aggressive behind-the-meter, or BTM, generation models. BTM refers to power generation systems located on the customer side of the utility meter, providing electricity directly to the facility. This is a sharp contrast to highly constrained regulatory environments like Maryland. As this document shows, Maryland's aggressive climate laws tightly constrain new gas expansion. Any new infrastructure projects here must be explicitly framed as transitional or decarbonizing, like shared thermal networks that use ground source heat pumps, in order to survive scrutiny from the Public Service Commission. Accurately mapping the local regulatory posture state by state dictates the exact commercial structure and ultimate viability of every single large load gas deal. To execute this, the organization has to replace ad hoc project groups with a formalized cross-functional deal team that blends enterprise and state-level staff. The 90-day roadmap requires locking in a RACI model, validating state tiering, establishing AI intake workflows, and setting Year 1 KPIs. RACI stands for Responsible, Accountable, Consulted, and Informed, which is a matrix used to clarify roles in complex projects. KPIs, or Key Performance Indicators, will specifically measure RFP win rates and cycle times. Disciplined, immediate execution of this exact roadmap is the only way to move from a theoretical strategic vision to securing that targeted $28 billion in capital growth.